how's it going? Today we'll be coding the famous game Flappy Bird from scratch using Python and Pygame. For this, I do expect you to know some basic Python, like looping, classes, and other basic stuff, and I'm gonna try my best to explain some of the Pygame along the way. Alright, so let's get right into it. So Pygame is basically a library we can use in Python. It simplifies a bunch of functions for us, so we don't have to create them from scratch. And we'll see some along the way. So first, let's import Pygame. So now we have access to everything the library has to offer. Now, in order to actually use Pygame, we have to initialize it. You don't have to do this for every library you ever come across in Python, but for Pygame, we have to type pygame.init in order for us to actually use everything that it offers. So first, we need to create two things. We need to actually create our screen, and we need to create our game loop, which is our refresh rate, and it updates the screen every, I'm gonna have for this game, we'll do 30 frames per second. So 30 times a second, our game will update. So first let's create our screen. Screen equals pygame.display.setMode. And then here, it's gonna ask us for the size of our screen. For this game, I'm gonna do 1000 pixels times 600. And then now for our actual game loop, we first need to create a clock, and that's going to be pygame.time.clock. Alright, now for our actual game loop, while true, so this runs forever, we want to do pygame.display.update, and so this is going to update our display every time this loop runs. And then we have to set how many times we want it to update. So clock.tick 30. So 30 times a second, the Pygame display will update. Alright, so now this is a working game, I guess. But one thing we want to do is when we close our game or close our program, our Pygame tends to like freak out and stuff. So we need to create a few lines of code that allow us to safely close the window. So for event in pygame.event.get, we're going to do if event.type equals pygame.quit. This is just checking for if someone quits the program. So what this event in pygame.event.get means is basically every time this loop runs, there will be an event that Pygame registers, like clicking a key or, someone quits the program. So whenever an event like that happens, Pygame will add it to a list of events that it keeps here. And so we're going to loop through each of those events, see if one of those was the program quitting. What we want to do is first pygame.quit. So Pygame quits and stops running. Up here we initialized it, down here we have to quit it, and then exit, just to exit our program. Alright, so now this is the basic Pygame game loop that is the beginning of every Pygame game. So now if we run this, we can see a nice big screen that we have here. And we can close it safely. Alright, so now let's actually get into creating our game. So first, what I want to do is I want to create our bird mechanics, right? So for our bird, I'm going to use a class, right? So we're going to create a class, call it bird, and what we want to do is we want to inherit the abilities that Pygame library gives us. And so to do that, we're going to for an argument, or in the parameters, we're going to write pygame.sprite.sprite. So yeah, our bird is going to act as a sprite, and we're going to use some of Pygame's built-in functions to help us do that, so we don't have to write everything from scratch. So let's first initialize our class, def init self, and then in order to actually inherit what's in the parameter, we have to do super dot init and that's it. So now we can use all the sprite mechanisms. Alright, so now that we have our class, I want to import our Flappy Bird image. So I have one saved already. So what I'm going to do is bird image equals pygame.image.load, and here we need to enter in the file location. And so this is a way you get any image into Pygame and you're able to use it. You have to use this function here. And now what we want to do is we want to assign this image to our class. So what we're going to do is self.bird image is equal to our bird image, and we also need to create a rectangle for this, and that's basically going to allow us to change the positioning and detect the borders of our bird. So self.rect equals self.birdImage.getRect, and I'm going to center it in the middle of our screen, which would be 500, 300. And the thing is, in Pygame, the point 00 is not the center of our screen. The point 00 is actually the top left of our screen, and then Y increases as you go down, and then X increases as you go to the right. So our center would be 500, 300, and not 00. Alright, now in order to actually get our bird onto the screen, what we need to do is we're going to need to first create our class, or create an instance for our class. So what I'm going to do is I'm going to type player equals pygame.sprite.group single. And so what this is going to do, this is going to create a group single of sprites for Pygame. That's going to be our single player, the bird that the player is going to be controlling. And to player, I'm going to add an instance of the bird class. Alright, so now if we come into our game loop and we have our instance created for our class, I'm going to first screen.fill blue. This is going to give us a nice blue background that's going to look like the sky, like in the original Flappy Bird game. And after that, I'm going to do player.draw screen. So what's going to happen here is Pygame draws things, or puts layers onto your screen in order. So first it's going to fill our screen, completely cover it in blue, and then on top of that, after, it's going to draw our bird. So let's give this a test run. Alright, so now let's give this a test run. Oh, this should be image, not bird image, my bad. And this should be self.birdImage. Alright, now here is our bird, and as you can see, it looks huge, so I want to scale it down. And so in order to do that, I'm gonna come here, and when we set our self.image equal to self.birdImage, what I'm going to do instead is I'm going to type pygame.transform.rotozoom, and this is going to allow us to scale and rotate our bird image. And so what I'm going to do, I'm going to do 0 degrees for the angle because I don't want to rotate it, and I'm going to have it be 0.15 scaled. So now this looks a lot more realistic as to the size of the bird in the actual Flappy Bird game. And here we want to do self.image.getRect instead of self.birdImage. Alright, now that we have our bird working, or we have our bird showing up on screen, we can get into the actual functions of our bird, including the jumping up and down. So first what I want to do is I want to adjust the position. I'm going to have it be at 200x instead of 500, so that way it starts back here. And what I'm going to do is I'm going to create 2 new variables up here. I'm going to do bird velocity equals 0 and gravity equals 10. That's just rounding up from 9.81. It really doesn't create a big difference. Alright, so what we want to do with this here we're going to come down here, and in order to actually have our gravity affect our bird, what I'm going to do is bird velocity minus equals gravity. So that means the bird velocity will decrease by 10, and we want it to do that every second, but right now our game is updating 30 times a second. So what we're going to need to do is divide gravity by 30 to get the change in gravity of 10 meters per second. And up here in our class, I'm going to create a new function. I'm going to call it def update. And what I'm going to do is I'm going to do self.rect.y. Oh, and I need to pass in self here. And this is basically the bird's y position, and I'm going to subtract the bird velocity from it every time this updates. And in order for this to actually update, I need to put it in our loop. So player.update. Right now, if I run this, the bird should start to fall. Yes. Alright, now let's include our jumping. And so what we're going to do is, remember here, we're checking for events, and one of these events can be pressing a key. So what I'm going to check for is if event.type is pygame.keyDown. Down. What we're going to do is check if event.key equals pygame.key space. So spacebar is going to be our main form of communication with the program. What we're going to do is we're going to set the bird velocity equal to 6. And so now what this will do, if we run our program, as it's falling, I press the spacebar, it jumps up. And in the actual Flappy Bird game, we see the bird changes its angle when it's going up or down. So we also want to do that here, because this just looks weird. It's just floating up and floating down while looking forward the whole time. So what I'm going to do here is I'm going to come back up to the class, and here when we created self.image equals rotozoom of our original image, what I'm going to do is I'm going to call this self.bird. I'm going to create a new attribute. I'm going to call it self.bird image neutral. And what we're going to do here is this is going to be equal to this, our bird looking straight. And then I'm going to create a new attribute, self.bird, and I'm going to call it bird image up. And what this will be is this is going to be the same thing, except here where our angle was originally 0, I'm going to have it be 45. And so what this is going to do is it's going to angle our bird looking 45 degrees up, and then I'm going to do the same thing with down. So bird image down, and I'm going to do negative 45 degrees for it to look down. Then here I'm going to, as a default, I'm going to set self.image equal to self.bird image neutral, and then we're going to create a new function in here for changing the skin of our bird. So I'm going to call it animation, passing self. And so what we're going to do is if the bird's going up, it's looking up, and if the bird's going down, it's looking down. So if bird velocity is greater than 0, we want self.image to be equal to self.bird image up. And if bird velocity is less than 0, I spelled it wrong up here. Alright, here we're gonna, if it's going down, if the velocity is less than 0, self.image equals self.bird image down. And then finally, we're in the update function, because we don't want to be calling player.update, player.animation. In our update function, we'll just run self.animation. Alright, now if we run this, it should work. Yep, we can see I'm pressing jump and it's going up and looking up, and then as it starts falling down, it looks down. Alright, that's our bird function pretty much complete. One last thing I'm going to do is add the sound of the bird jumping. We all know the iconic sound from the actual Flappy Bird game, so what I'm going to do that is I'm going to enable, so in order to do that, I'm going to enable the sound functionalities of Pygame, and I'm going to do that by typing pygame.mixer.init. And so this is just going to enable the sound, and I'm going to create a variable called flap sound. I'm going to set this equal to pygame.mixer.sound, and I'm going to pass in the file. And then it's just one more thing. Down when we have our key pressed, all I'm going to do is flapsound.play. Alright, now if we run the program, we should hear the flap sound. There it is. Alright, now that we have our bird mechanics all set up, let's move on to the obstacles. So for the obstacles, I'm going to create another class. I'm going to call it obstacle. And again, we're going to pass in pygame.sprite, so we can use the sprite functionalities. And then def init. Oh, that wasn't supposed to happen. Pass in self. And then finally super dot init. Alright, now let's create the obstacle image. So I'm going to call it self.obstacle image, and that's going to go to pygame.image.load, and then pass in the file name. Alright, and then I'm going to do self.image equals self.obstacle image, and self.rect equals self.obstacle image.getRect. Just the basic setup that we need to do. And then again, I need to do the same thing for this obstacle. I need to actually create the instance. Obstacle equals pygame.sprite. And now this time, because we're going to have multiple obstacles, I'm going to have it just be group and not group single. And then I'm going to do obstacle.add. I'm going to do one instance of the obstacle class. And then down here, I'm going to draw obstacle.draw screen. And now let's see how our obstacle looks. Alright, there it is. It's massive, and we definitely need to change the size of that. So let's go up here, self.obstacle image equals pygame.transform .rotozoom, and we want it to do self.obstacle image 0 degrees, and I'm gonna do 0.45. And for the center, I'm gonna have it be at center equals 500, 300. And let's see how this looks. Yeah, that's a much better size. And as you can see, there's only one obstacle, so I'm actually gonna have to create 2 obstacles. So what I'm going to do is here, I'm gonna call this upper obstacle and upper obstacle.add, and then below that I'm gonna do lower obstacle equals pygame.sprite.group, and then lower obstacle.add obstacle. And now what we're gonna need to do in order to change, the positions of these obstacles, is we're gonna need to create a parameter for each. So what I'm gonna do up here is, in addition to self, I'm gonna create the obstacle type. I'm gonna ask for the obstacle type. So for obstacle, the upper obstacle, we'll just pass in 1. For the lower obstacle, we'll pass in 2. And then here, when we create the obstacle image, I'm going to create one self obstacle up, and I'm going to do self obstacle image down. And this is going to be the same exact thing, except we're going to rotate it 180 degrees. And then what we want to do is we want to check for the type. So if type is 1, what we're going to do, that's the upper obstacle, so self.image equals self.obstacle image up, and then else we're going to do self.image equals self.obstacle image down. And then we can delete this line. Alright, now if we come down here, we can draw both obstacles. Lower obstacle dot draw screen and upper obstacle dot draw screen. Alright, let's run this. Oh, there's an error. Self.image equals self.obstacle image up. Obstacle has no. Oh, this should be a single equal sign. And while we're here, let's change this to self.image and not self.obstacle image, just so in the future we don't run into any problems. Alright, now if we try running this program, yep, there we can see both obstacles. Alright, now we need to position them correctly. So first, before we position them correctly, we want them to spawn let's say every 1 second. So what we're going to do in order to make that happen is we're going to come down here and we're going to create a custom event. So we're going to call it obstacle spawn, and that will be equal to pygame.user event +1. And you always want to add that +1 because Pygame has some of its own events that you don't want to mess with. So always add that +1. And what we're going to do, pygame.time.set timer and obstacle spawn, and I'm going to say every 3 seconds. So 300 milliseconds. And so now what we're going to do down here is if event.type equals pygame if it equals obstacle spawn, then we're going to come here and we're going to add the lower obstacle and this upper obstacle. Now if we run this, you see it waits some time, then they spawn in. Alright, now to set our positioning, we want them to spawn off screen and above and below each other. So what we're going to do is if type equals 1, so the obstacle is the upper obstacle, what we're going to do is self.rect equals self.image.get rect, and what we're going to do instead here is we're going to have top left of our rectangle equal to, we want our x coordinate to be just off the screen, so we're going to make it 1000, and I'm just going to add 10 just so it takes that tiny extra bit of time so it looks like it's rolling onto the screen. And then our y value, I'm going to have it be like 150 or something. And then for the lower obstacle, we'll do same x coordinate, and then I'll just have it be 350. We want the obstacles to glide towards our bird, and what we're going to do we're going to create a new function here, I'm going to call it movement, and I'm just going to do update. This will be our update function for our obstacle, and all I'm going to do is self.rect.y or x minus equals 10 and pass in self. So every time the game updates, our obstacle will have moved 10 pixels to the left. And of course we want to add that in here. Lower obstacle.update and upper obstacle.update. Now let's run this program. Here we see them rolling in. That clearly our positioning didn't work, but our timing does work. So let's go up here and see what we did wrong. Oh, for one of them I did top left, for the other I did center. That's my bad. Top left. Alright, let's see if this makes it any better. Okay, so clearly we need to increase the height of both of them. I'm going to go 250 here and just 50 there. Alright, we're going to need to do a little more. I think this is going to have to be -50, and I think we keep this the same. Alright, there we go. So we can see this is working now. I would like a little more space between them, so I'm going to make this 100. And obviously we don't want the height to be the same every single time. We want it to be random heights for the obstacles. So in order to do that, we're going to need to add another library. It's called random, and we need one specific function from that library. So what I'm going to do, from random, which is the name of the library, I'm going to import randint. So what this function is going to allow us to do, if we come down here, I'm going to do randint integer from -120 to, let's go -50. And then same thing here, or actually I'm going to select these beforehand. So we're going to pick our randint from -120 to -150, and this is going to be our y coordinate. And so our upper one, its y value will be the y coordinate. And then for our lower one, we're going to have it be y coordinate plus 100. So there's always a 100 pixel gap in between our two obstacles. And let's see. Okay, so that did not work. I'm going to create a bigger gap actually, I think. Let's just go 300. Yeah, that's much better. It's still a little small. I think I'll just add 50 onto the 300. I think that makes a big enough gap for us to actually play the game. Alright, yeah, there we go. Oh. See, why is it doing different spacing? That's weird. Why? Oh, okay. I see why that problem is occurring. It's because every time a obstacle is getting, or a lower and upper obstacle is getting generated, they're each generating their own random y coordinate. So we actually have to do this outside of the class as well. We're gonna have to come in here, and here we're gonna have to do this y coordinate equals that, and then in here I'm gonna have to pass in another parameter, y coordinate, and up here we're gonna need to accept the y core. I'm going to name it y core just so it's different from that. So y core and y core plus 30. Alright, now hopefully they spawn at the same distance from each other every single time. Okay, so we'll definitely have to increase the distance between the two. Let's go 400. Let's see if that looks good. Alright, yeah, this looks much better. And we can let the top variable go down even more. Let's have it go down all the way, maybe even to 300. Oh wait. All the way down to 100. Now let's make that just 50, negative 50. Yeah, that's much better. Alright. And I can also, I think 3 seconds is a bit too much. Let's try 2 seconds. Alright, now that we have our obstacles working and our bird working, now we can work on our collisions. So for our collisions, what we want to do is check when one image touches the other image. And typically we would do that with our rect values, but unfortunately my images are not perfect at all. So what I'm gonna need to do is check pixel to pixel. So when the pixel of the object collides with the pixel of the bird. And in order to do that, we're gonna need to use masks. So what we're gonna do is here when we create our recs, we're also going to create our masks. So self.mask equals pygame.mask.fromSurface from, and then we're going to do self.image. And I'm just going to copy and paste this exact thing for our bird class. Now what we're going to do down here is in the game loop down here, what I'm going to do, here, we're going to first, because we have two separate groups for upper and lower obstacles, we're going to need to check them separately. So first I'm going to do upper hit, and I'm going to set this equal to pygame.sprite collide. And what I'm going to do is I'll first type it out, then explain what's going on. Player.sprite upper obstacle false, and pygame.sprite.collide mask. And so what this basically is this is a boolean value here, and it's going to check if our player sprite collides with anything in the upper obstacle group. False basically means is if we want the obstacle to disappear or not. We don't want it to disappear, so it's false, and we're going to do the mask collisions, not just the rect values. And then I'm going to copy this exact same thing. We're going to do lower hit, lower, and lower obstacle here. Alright, now that we're checking if... Alright, now that we have these variables, we're going to do if upper hit or lower hit. Alright, now we need to create some infrastructure around, our game and, game over and stuff. So I'm going to pass this for now. And up at the top, I'm going to create game on. And this is going to be equal to true. And now we're going to need to create conditionals, so some things only run when the game's true. The first thing we can do is down here in the events panel, if event.type equals pygame.keyDown, and we also want to check if our game is actually on. So and game on, then only the jumping will work. Same thing with the obstacle spawn. And game on. Then we're going to come down here in our game loop. We're going to do if game on, and then in here I'm just going to tab all of this to under there, as well as this gravity. We'll have this be our first thing that happens. No real reason, but yeah. And so now if upper hit or lower hit, we're going to do game on equals false. Alright, now if we run the program, when I hit an obstacle, everything should pause. There we go. And now none of my controls work. Alright, now one final collision we want to check for is if it hits the floor. And if it hits the floor, that's also a game over. So here I'll do elif, or I'll just add it up here. So here I'm going to do or player.sprite.rect.bottom. So the bottom of our bird is greater than, what was the size of our screen? 600. So if it's greater than 600, we'll call it game over. So let's also test that. Yep, that's also game over, everything pauses. And I might just make it 550 just for it to look better. Alright, now let's create an official game over title. And in order to do that, we have to add a font. So to add a font in Pygame, all we need to do is font equals pygame.font.font. And now here, you're going to need to enter in the file of your font. I'm just going to do none and use the default Pygame font. And I'm going to give it a size of 100. So now if we come down here, so when this happens, we're going to first need to create our text. So game over text equals font.render. I'm going to do game over in all caps. True, this doesn't really matter. I can't. And then I'm going to have the color be red. Then we need to create the rect, just like everything else. Game over rect. This will be game over text dot get. Dot get rect. And I'll have the center of this be right in the middle of the screen. And then we're going to use the classic way to add a surface onto the screen. The default way to do it, if you're not using classes or anything, or sprites, is just screen.blit. This will add whatever surface you have. For us, it's game over text, and into its rect value. So game over rect. Now, when we die, it should show a big game over. There we go. And now, the final thing we're going to do is add our scoring system. So up here, we're going to create a score variable set equal to 0. And what we're going to do is, if our game is on, where did it go? We're going to check. If obstacle.rect.centerx obstacle.rect.centerx is equal to player.sprite.rect.centerx. So if both obstacles have the same value, or if both the obstacle and the bird's sprite have the same value, what we're going to do is add a score. So score plus equals 1. And we're going to have to loop through every single obstacle in the group. So for obstacle, and we just need to pick one, either the upper or lower obstacle, because if we do it for both, it will add 2 points. But for our case, those two basically count as, the upper and lower count as one obstacle. So we'll just do upper obstacle, just randomly. And alright, so now our score is going to increase every time we pass an obstacle. And we also need to show this. So we're going to come down here, outside of any, because we want our score to be seen even after the game's over. So outside of the if game on, or if we die, we're gonna do score text, and it's just gonna be the same thing, font.render, and I'm gonna use an f string. So I'm gonna use an f string, so score, and then I'm gonna do our score variable value, and then true and white. I'll have this one be colored white, so score text rect equals score text dot get rect. And I'm gonna locate this one at the top left of the screen at around 2020, so it has some margins. And then finally put it on the screen, screen.blit score text at score text rect. Alright, now let's run this. And we have our score. And it did not update for some reason. Let's check why that is. Alright, so the issue is we're checking if the positions are equal. However, we're moving our obstacles 10 pixels every time the game refreshes. So a lot of the time, the obstacle is just missed. The obstacle and the bird are just 1 pixel apart, so it doesn't count as a score increasing. So what we're going to do instead is we're going to see when our sprite passes the obstacle. So we're going to see if when the obstacle's x value is less than our sprite's x value. Now the problem with this is, as soon as the obstacle passes the sprite, the obstacle will always be behind our sprite. So what we need to do is we're going to need to create a new attribute here, and we're going to do self.scored. This equal to false. So if that obstacle has already been scored on, we don't want it to count again. So if this is true and not obstacle dot scored, we're gonna do obstacle dot scored equals true. So now every time we pass that obstacle can no longer be scored on. So now if we run the program, as soon as this obstacle goes behind us, it increases, and that obstacle cannot be scored on again. Alright, so this is your finished product. So this is your finished Flappy Bird game. I really hope you guys enjoyed watching the video, and I hope you learned something from it. Please comment if you have any questions. Subscribe if you want more, if you want similar tutorials that are coming up very soon. And yeah, see you next time.